Last week we saw how we are meant and how to interpret.
So that's what they call.
Now it's under the of the main
But it's still very weak. If you are the one, you understand. All right, so for those who were not here yesterday, on Monday, let me just make a vivid revision before we proceed. Okay. So we said that with descriptive is one of the first sections when you are dealing with quantitative study. All right. You have to start by descriptive means to describe. Are you getting? You have to describe your data. How is your data? So there are some parameters that you use to describe your data. Are we there? You have measures of central tendency. You have measures of spread or dispersion. Are we there? You have measures of what? Measures of frequencies. And under measures of central tendency, you have the mean, the mode, and the median. And under measures of spread, you are looking at range, minimum, maximum, standard deviation, and the variance. They have measures of distribution which has to do with number one, ketosis. I have one, skewedness, these two parameters. So when you're talking about descriptive summarily, you have to talk about these parameters. It's very important for you to understand the whole concept of descriptive, because it is from descriptive that you know the state of your data. Are we there? It is from descriptive you know if it is parametric or non-parametric, or you know if it is normally distributed, or it's not normally distributed. If it's normal, you can move on your parametric differential. But if it's not normal, you can either transform it or you use what? Distribution free or non-parametric analysis. Is it okay? So please, what we try to make sure that we understand here are the major concepts. If you don't get concepts clearly, you will not be able to execute them well. Then there's also what we call the standard deviation of the mean. Standard deviation of the mean is very, very important, especially those who are doing experimental studies, or those who are doing quasi-experimental research, or you are doing true experimental study, where you have what? The control group, you have replications, you have randomization. Because your standard error of the mean tells you what? The accuracy when it comes to your replicates. If the standard error is too high, it's not good. It tells you that the replicates, maybe you did not really collect them well. You don't really collect them well. So standard error of the mean, if you look at most publications, you see that some of them, they include the standard error of the mean. So it's also important for us to understand the rationale behind the standard error of the mean. So in front of us here, we have sample data set 2014. And I believe we are versed with measurements. You must understand your measurements very well. If you are dealing with a data which is scale, if you are dealing with data which is ordinal, what is an example of an ordinal data? The result of a race. But what is the mean? What is the one? What's the ordinal? Yes, data that follows a specific order. It's quite important for you to not to cram these things anymore. Because sometimes student crams alone and they're not able to differentiate. For example, you have academic qualification, follow an order. Administration follows an order. Then what is nominal now? Pardon? So you cannot say that. You cannot say that. For example, gender is it an ordinal data? It's nominal. Then what's an example of scale data? Example of a scale. Random scale. Yes, the kind of data which you are talking of scale. Madam, I would like to hear from you. Okay, you're with me. All right, that's good. So you have heard of continuous data. You've heard of that. You have heard of discrete. So normally, it's quite important you get the concept clear because when you come to analysis like linear regression, ordinal regression, nominal regression, you must be able to understand what differentiates all of them. Are we together? Yes, you must be able to understand. Because if you don't get the concept well, along the line, you will not be able to interpret them well. Is it clear? So in front of us here we have data. So today, the main rationale for today is, so the aim for today is for you to be able to know how to analyze, for you to be able to know how to describe your data using the various aspects you have made mention about earlier. So have you tried to do this maybe before or within this class? All right. So your eyes should either be on the screen so that you follow up. So for you to analyze descriptive, you have to go to analyze. Analyze. Please, for the first time, you just watch, please. I'm going to take it over. So you go to analyze. You go down to descriptive. You go down to descriptive. On descriptive, you have frequencies, descriptive, explore. This is crosstab. Crosstab, which I'll be talking about, what? Chi-squared. You've heard of chi-squared, right? Especially those in public health. You have to start looking at associations between your predictors of what you're investigating or your independent variables and demographics. Because most often they deal with what? It's not continuous, it's mostly nominal, ordinal. So it's also inferential for you to know maybe differences, associations between the various parameters you're doing. And so you have what we call the probability plots, ratio, quantile, occur plots. So first, we are going to start with the first, which is frequencies. So take for example, I want to analyze smoking, English. So here you have 1, 2, 3, 4, 5 legends, right? So the first is statistics. And here it is being grouped. First section has to do with percentiles, central tendency. So you have 5 functions here. 4. Here you have dispersion. which is 6, or spread. And this section has to do with what? Distribution. You have to tell us a distributional pattern. So we have to, when we come here, we discuss a lot. Because for skewness, it is either it's positively skewed, negative, or it's okay. For ketosis, you have mesocutic, you have platycutic, you have leptocutic. We are going to go there. So normally by default setting here, if I just press continue and I think okay, it's going to compute for frequency and percentages. Are we there? Is it clear? So if I want to add other parameters, I can say, let me just look at this, but let me just look at this 4% tendency. Let's continue. Charts, bar charts, pie charts, and histogram. These are the charts available for SPSS. But you know that there are so many charts. Do you know that? There are many. You have stack bar chart. That's a modified form of bar chart. But it's not here. And the kind of charts you plot here, when you export them, it does not obey the formatting of your general document in terms of what? The font size and the font style. You might manipulate on the font size, but not necessarily the font style. Is it okay? So if I click on OK, you see I have your output. So let's focus on smoking. So you have 1, 2, 3, 4 sections for the frequency table. The first section gives you the frequency. Frequency is a synonymous word. Number of occurrence, right? Frequency. The second section gives you the percent. The third gives you the valid percent. Now, what is the difference between the percent and the valid percent? The difference between the percent and the valid percent is that this percent here gives you the general percentage, including the percentage of the missing value in the data set. Now, valid percent exclude that of the missing value. Is it okay? Valid percent exclude that of the missing value. If you don't understand it very well, you can compute and interpret results and will not sum up to 100%. So sometimes some respondents, they don't answer your questionnaires like completely. Maybe they can omit a question and it's going to present you missing system. Okay, you can decide not to include the missing system. What you do is that you take the frequency and you take the valid percent. But if in case your supervisor or your administrator wants you to present both the frequency and the normal percent, you take the first. It's okay. You don't include that of the missing value. But know that when you don't, all right, it's okay. So what I'm saying is that for the valid percent, is independent of all the missing values. All right. Now take an example that if I want to plot some charts, let's say bar chart for smoking. Let's just use this nominal data here. You have non-smoker, past smoker, current smoker. That one is very explicit, right? One of the main significance of charts is for also for vision, so that those who are sitting far or those who are having problems with their eyes can easily see. So it's quite important to know which of them to use, because you have histogram, you have bar charts, you have pie charts. There are so many line graphs, yes, box plots, bubble plots. Okay. So the next descriptive here does not include the frequency and the percentage. So if I come to descriptive, I want to look at gender, and I look at weight options. You have to decide which one to use. So if I'm looking at dispersion, I don't need central tendency. I press my continue and I click on OK. You see that here, there's no frequency and percentage. Go straight to the point. Go straight to the point. Now, before we go to the practical session, I would like us to try to deduce some interpretations for our data set. Now, when you look at weight, which is a continuous data, causally gain, stand up, okay, is going to help you. And I'm just on sleeping too. You will not sleep. The spirit is willing, but the flesh is weak. Okay. So, maximum value, minimum value, the range. Your range of your data should not be too wide. It's true, right? Because when it's too wide, it's a problem. It's especially for your study. If it's too wide, it gives an idea of what? The presence of outliers. There might be the presence of outliers. Are we there? Don't expect in a study the range to be too wide. And even your standard deviation, what is the formula for standard deviation? How can you deduce standard deviation? Okay, square root of variance. What's variance? You want to square root something without knowing it. X minus x bar with it divided by what? Sample size, population. Okay, it's important for you to know them. If you don't know it well, you might not be able to interpret well. So the individual value should drop for what? The mean. Now, the numerator will always square it to move at what? The negative signs. We square the numerator. That's why when you go to Excel, you have two formulas. You have the formula variance for what? Population, variance for sample. So you have the individual values to deduct from the mean divided by what? Either big N or small n. So we don't expect that this deviation of the data to be too wide. Okay? So descriptive with respect to dispersion gives us a clue of how spread your data will be. So we have looked at in this context dispersion. Are we there? So let me just give us a brief resume before we begin, so that you don't have any challenge, right? Now, when you go to this to analyze descriptive, the first you have frequencies. We're saying that if you need charts, in fact, the first section is mostly for nominal data. I mean, if you want to look at gender, blah blah blah, frequencies and percentages, you can look into all that. Okay. The second section has to do with dispersion, distribution, and two functions of central tendency, which is what? The mean. That's why we come here. You have just what? The mean and the sum. The other parameters are under frequencies. So at this stage, is there any question? Is there any question? We'll just proceed. No question, right? Okay, so let's get to practical design. So I'd like us to look at, to analyze results for Number one, gender and outlet. They look at measures of central tendency, measures of dispersion for height and weight. So height and weight, you look at measures of central tendency, measures of dispersion. For gender and outlet, you look at measures of, measures of frequencies, sorry. Measures of frequencies. So we have 10 minutes. We have 10 minutes for that exercise. The practical together. All right, you go to analyze. You go to analyze, you go to descriptive and frequencies. So in frequencies, you're analyzing results, you're analyzing gender and outlets. Gender and outlets. So you have frequencies, gender, and outlets. Oh my God. Is there any challenge? This is any challenge?
Yes, sir. Hello, sir.
Yes, I'm getting please.
Yes, I can only hear you talk. I see very little of what you are doing, except when you come to when you're working on the app. Every other thing that you're explaining, I can't see it. So I always see when you come this and you picked the first one where we had English and where you picked up English, and the other one you are working on. after that, everything you were explaining, I was only hearing it, but I could not see what you were doing.
Are you seeing the screen now?
Yes, I'm in the screen now.
All right. So the challenge is that you cannot go through, you cannot analyze for frequency and percentage.
You said I'm on frequencies. I've picked up outlets and I picked up outlets.
Where?
Please, where you are, there's
I
a lot
picked up
of
outlets.
noise. Where you are, please, can you try to, because I'm getting some noise at the background.
Yeah.
Yes, right on. You said, now are you seeing my screen?
Hello.
Yes, I'm seeing your screen now.
Okay.
The opposite mortuary.
Yeah. Are you at this?
Okay, you see some small roads where you go from inside. You go about some fence.
Some other person. That mic, the noise is not from my side. It's some other person that can also hear the noise.
Yeah, who can that be? Are you Nestor?
No, I'm Frank. Look at the noises from the other participant whose mic is also not who was not muted. Because on my side there is no noise, but I can hear someone giving direction through his own mic.
I'm not trying to mute.
Hello, sir.
Yes, it's okay now. Right on.
Okay, I'm saying that I've gone to analyze, I've gone to frequency, and I've chosen gender and outlets already, but I don't know
Yes.
what next to do because I could not really follow up on the previous things
Okay,
you
I
were
said go
explaining.
to statistics. Go to statistics.
Okay, statistics. Yes, I'm there,
Yes.
and I can see quantities, get points.
Yeah, so by default setting, this one will compute your frequency and your percentages, okay?
Okay.
So just press on continue. You go to chart.
But they are
you
not
on
selected.
chart?
Yeah, all the things
Yes,
are not checked.
You are the one who's going to select what you want.
Okay. So I should go to chat.
You are the one to select what, yes, go to chart.
Okay.
So on charts, you can take any of them.
Okay.
Take pie chart. Are you there?
But where I am, I can okay after when I say I should select mean or median or mode on all this before I go to charts.
No.
I'm still where I have quantities, get points, and I've not seen charts there.
Wait, are you seeing my screen now?
Yes, I'm seeing your screen now, and that's actually where I am now.
Just click on OK. Click on continue.
Continue. Okay. Yes.
Go to chat. Go to chat now. Please try to.
I'm there.
You take any of the charts there.
Okay, I've taken bar charts.
Then you click on OK. And you have your output.
Okay. Yes, I have it.
So it's okay, right?
Yes, thank you, sir.
Okay, so we go now to the next section down on descriptive. Descriptive under frequencies.
Under frequencies, yes.
So, yes. So here we are dealing with, I would like us to analyze just for continuous data. So you have height and weight. Those two.
Yes.
And
Yes,
take
sir.
options. Take
Yes,
options.
I'm there.
Dispersion, mean and
yeah,
mode.
Okay, mean and mode.
With dispersion.
I've taken mean already.
I don't.
Okay, sir.
You press continue and you take OK.
Okay. Yes, I have them, sir. Thank you, sir.
We'll go now to measure of dispersion and central tendency. Okay, you take weight and what? Interpreter. Those analyze and keep. Interpretation is about 60%. Okay. Yes, you analyze it. No, the balance that we can hide. Analyze. Analyze. That part. Okay. So please, you give us interpretation for height. You have missing value. General angle. No. Just give us interpretation for height and weight. Mr. Franklin.
Yes, sir.
I
was following up. Hello.
Yes, I want you to interpret that for for the weight.
So, but I was following what we were doing. I realized mine is different, so I'm redoing it again.
Okay.
Yeah, I'll get back.
It's okay. Which, what's the SI unit? You're not putting SI unit. What's the SI unit of weight? Yes, that's how you have to communicate your findings. What is? No, it's not a matter of being said. We are talking of weight. And we are talking about weight. You have to know the SI unit of weight. It's true, right? If you are talking of time, what's the SI unit of time? Are we there? So you look at the weight. The SI unit of weight is what? Is it kilograms or grams? Okay, it depends the season. So use kilograms there. Okay. So try to interpret now using the SI unit. The standard error of the mean. So you see that the standard error is quite low. Look at it there. That's 2.2 kilograms. Very good. It tells a level of accuracy. Okay. It tells you that the people that they were involved in this study, they were not really that. That's why I look at the range. But when I look at the minimum weight, that's 101 kilograms. The minimum weight of 376 individuals was 101 kilograms, and the maximum was 350 kilograms. Do you think that that gap is wide? What's it again? What do you think? Okay, I don't think it's too wide. All right, let's go now to height. Madam, please, can you give us some interpretation of height here? Have you analyzed for height? Okay, are you clear with the concept of range? That's the distance, the difference from the maximum and the minimum gives you the range. So for height, the SI unit of height is what? Meters or centimeters? Okay, the SI unit of height is meters. If you are looking about meters, there implies that the maximum height of an individual in that study was 84.41 meters. Is it rational? Therefore means normally it's supposed to be centimeters. Because you have to understand it very well. It means it is centimeters, but you might want to report it in meters. And in that aspect now, you have to convert. Are we there? So it was collected in what? Centimeters. So you cannot tell me that individual is 55 meters. You interpret it and you're very happy. That's why analysis first, you must be cognitive. You must be rational. But take the data, you have to ask questions. If not, you will report rubbish and you're very happy. very confident. So you see that we had a total of 408 participants for this study. That's the first interpretation. And in that number, the minimum height of the individual was 29.41 centimeters. The maximum height was 84.41, making a difference, 55, making a difference of 29.41. Are we there? The average height among all of these participants was what? 68. With a standard deviation of what? 5.32 and a variance of 28. Now, if you look at the maximum individual from the minimum, you see that it's not that deviated. It's not that far. Are we together? But this does not end here. We have to look at the distribution. How is it being distributed? Are there some outliers? And in that distribution, we shall be looking at what? Ketosis and what? Skewness. But this is a study on its own, because when we are talking about checking for normality of data, we'll be looking at the PP plots. We'll look at scatter plots, the same thing. We'll be looking at what? Skewness, ketosis. We'll be looking at inferential methods of testing for normality, where we shall be looking at the Kolmogorov test, we shall be looking at the Shapiro-Wilk test. These are the two inferential or some of the inferential techniques to check for normality. Are we there? So let's not go too much into that for now. So I hope that at this stage, we're able to interpret something, right? We're able to analyze it at this stage.
Yes, sir.
Valley. I'll look into that, but I think maybe it's independent of the missing values. Okay. So that's what we call explore in SPSS. Let's go to the next section. The sample size. Yes, sample size is very important. So we have looked at frequencies, we have looked at descriptive. Are we okay with this speed? Or I'm too fast? Then it's okay. Now we'll look at explore. Now the section for explore gives you like a general analysis, general description, okay? General for your work. And even at this, we'll have the confidence interval, the lower and upper bound. So if you click on explore, you are going to have the dependent list, the factor list, and label cases by. So if I want to explore, let's say weight, and I want to explore, let's say gender. I'll come to statistics. You have outliers. This is when we are testing for normality, okay? Don't need that now. This is the same thing normality plot we test. So in this case, we must look at descriptive, okay? They adjust your interval. Know that there are three, here we mostly look at three confidence levels. Statisticians, we must look at three confidence levels. Number one, 90% confidence level. With an error term of what? 10%. Okay. We have number 2, 95%. Alpha level what? 0.05 or 5%. The confidence interval, 95%. Alpha level 0.05 or what? 5%. You have the last, which is what? 99%. Alpha level what? 1% or 0.01. Okay. Now you don't just choose it anyhow. You don't choose it anyhow. In the hospital, you are taking blood samples, you are working with alpha level of 90%. There are some cases you report that mommy is like this, you have diabetes. And if it is not true, you have a serious problem with that mother. Is it true? So you don't just report things anyhow. That is why when you go to the hospital to do your blood, you take your blood samples, you don't just take it once. Whether you want to take it for malaria or whatever, they don't just take it once, right? They will have to press on the finger. You are taking the finger about 3 times, right? You press it, you press again, and the last time. That one is to minimize error. Okay? So that you should not just take once. What if there's a problem with the surface? You come and tell me a result which is not mine. Okay? Anyhow, that's somehow out of the scope. But the major thing when we are talking about the confidence level is that when you're working with humans, your error term is supposed to be very low. Right? That's why normally those who are dealing with health, they're supposed to work with 99% confidence interval, 0.01 alpha level. Okay? But for those of us who are in campus A and doing other studies, you have 95% like some. All right. And so we are going to continue 95%. And I click on OK. You see that there's a table that gives you what? Descriptive. I think this. Pardon? Mr. Franklin, please, are you done with? All right,
Yeah,
so you're not seeing.
Yeah, I can only hear you talk, but most of the things I explain, I cannot see them.
All right, I'm saying that we are on Explore. We want to look at Explore now.
Yes, sir.
Are you getting me?
Yes, I'm with you now, sir. I can see the screen.
Are you seeing my screen well?
Yes, I'm seeing it now. Okay.
So go to Explore. Yes, you click on Explore. That's where we are. Okay, please.
Okay, sir, I'm with you now.
Okay, so you go to Analyze, Descriptive, Explore. Are you there?
Yes, sir.
So on Explore, you have dependent list, factor list, label cases by. So we are putting our variables on the dependent list.
I'm with you, sir.
Okay. So you do that and you take OK. You're going to have what I have on my screen here. So if you look at weight, you see that this last two talks about the distributional pattern, right? Distributional pattern. You have the interquartile range, you have the range, the maximum minimum standard deviation variance, 95% confidence interval for the mean, the lower and the upper bound. Okay. So it gives you a general summary of your results. Okay, so I'd like us to explore that for maths. Those who love maths. What's it again? Hello. I'm not here. You're far. You explore that for maths, please. Maths as a variable. Maths only. So you go to analyze, explore, you're using the dependent list. So highlight math and send it on dependent list. Statistics. Make sure that your descriptive, highlight your descriptive. Continue. You don't need plots. I click on OK. Click on OK. No, you don't need plots. Yes. Statistics, you click on descriptive. So, I believe at this stage, we have covered aspects of descriptive, which you can analyze, describe your data, and you report to your hierarchy, or to your employer, or to your supervisor, or report to yourself. So here we'll be looking at another concept, which is very, very important. Very, very important. We shall be looking at chi-squared. We are just going to introduce it. We'll just introduce a concept since it's quite important. So chi-squared is a method that we use. It's an inferential method, right, to test for associations. We also use chi-square to look for differences. Are we there? Also use chi-square to look for differences. Why is this so important? It is very important because it deals mostly with categorical data, or it deals with categorical data. Not mostly, it deals with categorical data. It is very, very important for you to get the concept of chi-squared very, very well, because there are studies that you need just descriptive and association and chi-squared, and that's all. Are we there? Yes. So there's parametric chi-squared and there is non-parametric chi-squared. There are two of them: parametric, non-parametric. So for the parametric, has to do with what? Two sets of data. Two sets. Are we there? Two sets of data. For non-parametric, this would how many? Just one. So we are going to look at parametric, and if we deem it necessary, we might go to calculate it manually for the non-parametric. Will you be okay by you? You like it? If you don't like it, leave it. Anyhow, it helps you to be dynamic with Excel, because there are some people that they don't just believe in you reporting data just with SPSS. They would like to see the observed counts. What do you mean by observed counts? What do you mean by expected counts? Because normally you don't present results without giving us your method of analysis. You don't do that anywhere. Do you get it? You don't do that anywhere with justification. Why are you using chi-square? Why did you use ANOVA? Why didn't you use Koskawalis? Why that one? That is why we are using a formula. You must understand the rationale behind that formula. Okay? Well, so that is why I'm saying that chi-squared, if you want to see most of those who work with categorical data in the lab, this is their inferential technique. Because chi-squared has to do what? P-value. Whenever you hear of inferential, you have to start with what? P-values. And if you are dealing with p-values, you must have your hypothesis, the null and the what? The alternative. Like the cohort 8 and 9 students, I told them, if you analyze, if you answer your exams without putting your hypothesis, I was like telling them in class that I deduct 2 marks. Because there is no way you present a PhD thesis, master's thesis, whatever research work, which is inferential. I don't tell me a hypothesis. It's not making sense. What is your claim? What is your claim for your research work? If you are working on something like you are looking at a research work looking at gender or the effect of premarital sex or pregnancy on students' academic performance, and you're looking at inferential technique, you must have your hypothesis. Is your claim that it affects or it does not? Are we there? Yes. So please, one thing you must note here is that Chi-square deals with categorical data. Never forget this one. Categorical. And categorical, we're talking about what? Nominal and what? Ordinal. Never forget this. Please, it's very important. You should not go and be using independent sample t-test where data is. Don't do that. Is it clear at this stage? Huh? So, we'd like to know if there's an association between weight and gender. Want to know if there's an association between what? Weight and gender. Want to know if there's an association between what? Weight and height. Is it that those who are tall, they have lesser weight or they have more weight? What should be a hypothesis? No, not what I've just said. What have I just said? State the hypothesis clear. Yes, but that is not, you have not stated the hypothesis clear. Even undergraduate, we don't accept that. Whereas you are trying to train yourself to be internationally recognized here. Null hypothesis. Null is a concept. Null means zero. Null means zero, right? You must have your null and the alternative. There are some cases where you have hypotheses for the main objectives and hypothesis for what? Specific objectives. State them clearly. Now, in this study, we want to see if weight has something to do what? With height. Okay, this is my null. I can say that weight has no association with height. Okay? Alternatively, weight has what? An association. You can say that weight has a significant effect with what? Height. Weight does not. Or weight does not for null. Weight has, right? It's now based on what you are investigating. Is it clear? Are you getting it? Because you must have a main hypothesis for every research work and specific. I want to it's good to understand these things very well. Because if you solve things like inferential and you don't conclude well, it's bad. It's not good. Okay? And please, there are 3 ways for you to test for significance. You should never forget this. Number 1, p-value. Write it down. P-value. Number 2, confidence interval. You have the p-value. You have what? The confidence interval. You have the f or the t value. Or you talk about the calculated and the experimented. You compare them. Pardon? You have the f, the t value. So we are going to get more details. So I want to see if there's an association between weight. So I click on weight. I want to see if there's an association between weight and what? Gender. Okay. Let's say want to see if there's an association between gender and height, right? Gender and weight. Gender and weight. Where is that weight? Why are you running? Now, I made a statement earlier that chi-square look at association between demography and predictors. It's not predictor, it's predictor. Or better still, let's just say independent variable. Okay? Yes, it's good to correct that. Now, for example, this is a PhD study or a master study. You go now to statistics. On statistics, I'm helping you. I know. So on statistics, you are taking chi-squared. Click on chi-squared. Huh?
Go on, where you reach for you don't.
Pardon?
Go where you pass here. Dot.
I'm going to come back.
Okay, they don't enter plenty.
Mr. Franklin, hope you are following up. Franklin.
Sir, I'm following up, sir.
All right.
I'm where you are right now.
Good. So you have chi-squared. You click on continue. You go to cells. You have the observe, expected. We need both of them. You have the row and have what? The column, right? Continue. I will take OK. Sorry. Error. All right. Sorry. Okay, so I said for chi-squared, we are dealing with categorical, right? But we see height is not the categorical data. It's not. So categorical data, you have what? Gender, you have outlet, then state. Then I think we have smoking there. All right. So let's take we're looking at gender and smoking. Who are those who smoke more in the tropics? Is it men or women? Men. Then the temperate. In the temperate, who are those who smoke more? Like we're talking about the white man land. It's still, are you sure? Okay. They said that what a man can do, a woman can do more better. I don't know if that concept is applicable there. Okay, so we have gender, I have smoking. Let's just look at the association between this. Let's look at those who can smoke. This is research work now. So here you have two tables. The first table gives you what? The observed and the expected count, right? The second table gives you the inferential. The first one has to do with what we call the Pearson chi-squared value. Pearson chi-squared. Sometimes scientists or researchers, they report their findings first with the Pearson chi-squared value and the p-value. Sometimes, if you are saying that there's a significant association between gender and smoking, in bracket, chi-squared equals 3.171, at df of 2, p equals 0.205. You see that? So, if you look at the asymptotic significance, there you see that it is not significant. Is it true? Is it true? Here, this is 0.205. Is it significant or not? It's very low. See, I now know that you're having a problem with significance. You have not understood the concept. Is it significant or not? Constantly again. You're not following up. Now, we said there are 3 ways to tell significance, right? You must understand this. You can never do experimental studies or inferential studies, without understanding how is data significant. There's no way. Now, we said there are 3 alpha levels that we use, right? 3 alpha levels that is mostly common here. We said 0.05, right? You have 0.01, I have what? 0.1, which is 10%. Now, how do you know if it is significant? Here, for example, there's the asymptotic significant value here. It is 0.205. You know if it is significant if this asymptotic value here is lower than the alpha value you are using for your study. Is it clear? I said lower than. I did not say equal to. There are some people that they may report findings with less than or equal to. It is very wrong. It should be less than, not equal to. So if you compute your asymptotic value is less than your alpha value for your study, it therefore means what? It is significant. It means there's an association, right? Do you get that? So 0.05 is equal to 5%, right? That's what we said now. It's the same like 5%, right? Now 0.205, is it equal to 0.05, or is it higher than 0.05, or is it less than 0.05? It's greater than, right?
Yes,
now,
sir.
if it is greater than 0.05, what is the conclusion here now? It's not significant. Please, you must, if you can understand just this significant today, I don't have any problem with you. In fact, whole of this week, because it is one of the key things, right? So, hello. All right, so if you look at it, you see that it is not significant, right? Now, when you now calculate or compute, and you see that it is, let's say 0.02, and your alpha level is 0.05, is this significant or not at that time? Significant, right? But if you compute and it's 0.05, it is not significant because equal to. Now, if you are using 99% confidence interval, don't go and report findings for 95%. Because you cannot be using 99%, knowing that it should be less than 0.01, and you're having 0.02, and your report that's significant. You have to be very careful the alpha level you're using. Okay? Pardon? Yes, less than 0.01. So it can be significant for 5%, 1%, but it can be significant for 10%, but not for 5% and 1%. It can be significant for 5%, but not for 1%. It can be significant for 1% and significant for all. It can be significant for 5%, significant for 10%. It's true, right? Good. So, you see that from these findings, Franklin.
Yes, sir.
As we proceed, if the screen is not being shared, notify me, please.
Okay, sir.
Good. So if you look at the observed count here, you see that non-smokers, we had a total of 297 known smokers. Are we seeing? We had a total of what? 297 known smokers for this study. In that 297, 149 known smokers were what? Were male. 148 known smokers were what? Female. So are we happy now that we have more women who don't smoke? Let's proceed. Yes, you can see it's not a punishment. I want you to relax. We don't punish here. We have received punishment from secondary school, primary school. Okay? You have to feel free. We are colleagues. Don't be standing up. Now, for past smokers, those who have repented, we have 13 of the past smokers were male, right? And 24 past smokers were female. So we see that more women they repent from smoking than men. So is it true in Africa? You're welcome, madam. Is it true in Africa? They have more women who repent from smoking than men. That? Yes. But what's the push factor? Is it inflation and retail price index in Cameroon? Because they'll tell you hundreds of 1 million, just gonna smoke. Okay. Now let's go to current smokers. Current smokers. This is what I like. We have 31 current smokers, of them being male, and 37 of them being female. So you see that in this study, we see that more women smoke than men. We see that, but we don't have any significant differences, right? More women smoke than men. 37 as to 31. The gap is not that wide, right? Yes. So you see that you can use chi-square to look at associations, as well as you can use chi-square to look at what differences, right? Yes. So summarily, we are saying that chi-square is for categorical data, right? You see how we did that for weight. It's not go now. Yes, because it's continuous. Now for continuous data, we'll be looking at number one sample t-test, independent sample t-test, dependent sample t-test. I'll be looking at analysis of variance or ANOVA. In the known parametric section, we shall be looking at Oscar-Wallis. We shall be looking at the Mann-Watney. You've heard of that? See, we have never heard of Mann-Watney U-test. We are going to talk about this when it comes to mean separations. So please, at this stage, is there any question? Or we'll go for break. What's the time? 4:48. Okay, the practical. No, I'm more interested in the understanding first. Is it clear, like comprehensively? Do you have any question? What's it? Is there any question? Is there any question? You have to answer. So I'm going to go back. So on analyze, okay. On analyze, you go to descriptive. On analyze, you go to descriptive. On descriptive, you go down to what? Cross tabulations. On analyze, you go to descriptive. From descriptive, go down to what? Cross tabulation. Cross tabulation. Are we there? Log in. Now, you select your variables of interest. They should be categorical. They should be categorical, which therefore means that I should not come and take weight and height. So we want to know if there's a difference between male and female in terms of what? Smoking. Okay? We want to know who smoke more and if there's a difference between male and female. So you come to statistics. Come to statistics here. Come to statistics. You click on chi-squared. Click on chi-squared. And you take continue. You come to cells. Come to cells. On cells, we are taking the observed and expected counts and the percentages for the row and the column. Observed counts actually is the data set there. Okay, like normally expected count, the formula is because sometimes you may have the observed but not the expected. So expected count is sample size divided by the number of variables. That you can get the expected count. So the sample size of a number of variables. This is just if you want to compute. It's clear now. So you have the percentage and the percentages for the column. When you have clicked on this, continue. Okay. So I said, you come to analyze, descriptive, cross tabulations, statistics, chi-squared, cells, observe expected the percentages, and okay. So if you do that, you are going to have this output here. we're going to have this output. So we're interpreting it by saying that based on the number of the frequency of observed count, you have majority of the respondents in total. In total, majority of respondents were non-smokers. We have a sample size here of 402, and in that 402, 297 of the respondents were non-smokers, and majority of them were female. Now, in that 402, 37 of them were repentant smokers, with majority of them being female. And lastly, 68 of them were current smokers, with majority of them being female. However, we did not notice any significant difference that exists between the male and the female in terms of smoking. Are we there? We're going to come back maybe sometime to this to look at other exercises. Are we okay at this stage? All right. We are going to do some, we are going to Excel that you can do some graph plotting too. It's important that we know that too. So the intercept between the row and the column in Excel, we call it the cell. And Excel is being used for diverse reasons. You can use Excel to compute. You can use Excel for financial records. Accountants also made use of Excel. And Excel is also good for tables because you can easily merge and merge table presentations. So in Excel, when you put an equal sign, it means you want to compute. You already send an information to the machine that you want to compute, right? So if I put an equal sign, and if I write average, for example, you see that it's only giving me some formulas, so maybe average down here. Are we there? But we are not to do that. We are to do a little bit of data exploration. We earlier said that when the charts that we have done in SPSS, you see that those charts, you cannot easily work on them in terms of the font style. If the font style is Calibri, you cannot change them to Times New Roman. You see? So some people will not accept. And if you want to change the font size, you all have to stretch it out. You cannot easily work on them. So it's good we also look at how to draw charts so that you easily present them, right? Now, generally, we have different types of charts and graphs. We did that last week. So you have the line graph. You have to know first when to use them. Okay? So if you are working with a study that has to do with, you don't have many variables, or sorry, you don't have many categories. For example, gender as a variable has 2 categories. You don't have many categories, you can easily use what? The pie chart. If you have further categories, about 5 categories, you can use a bar chart. Now, if you are dealing with interval data, you have age 0 to 10 years, 11 to 20 years, 21 to 30 years. You can use what? The histogram. Now, if you are dealing with data over time, for example, you want to know the level of inflation in Cameroon from 1960 to 2020. In that case, you have to use what? The line graph. so that you know if there has been a positive increase, a negative, or there has been a null. You use the line graph. We also have what we call the area chart. That gives you more, like, one of the rationale behind area chart is that it makes your line graph, or it's a modification, like modification line graph, which makes it more visible, right? You also have the bubble plots. You also have the stack bar charts. So whatever chart you are using, you have to know the justification of it. Now, to example, we have gender. Let's say we want to present something like gender. So you have male, is there hibernation of my machine? Or what? Okay. You have female. You have frequency. You have percentage. You highlight first. For those who are using Office Word 2007, 2010, want to click that, you delete it. You have it. We are pleading with you that you delete. You go and uninstall it. Install at least 2013 version. That one is old. So there are some functions, or there are some additions that is not present in that one. So when you highlight, for 2013 and above, you have recommended charts. For those who are having less than 2013, there's no recommended chart. That's survival of the fittest. So you click on recommended charts. All right, I'm clicking on recommended chart with that data. That's what the machine is telling me, that your mind are not serious. So how do I compute for the percentage here in Excel? How can I get my percentage? Are you seeing? How can I get my percentage? It shows that you need. How can I calculate this percentage in Excel? Okay, you start by, you have to locate your cell. So if you look at this cell, it is cell F2. Okay, this is F2. So I take F2, I've located the cell, divided by total. And what is the total here? 50 times what? Times 100. 40. That's all. Excel is very nice. That's why those who are teaching secondary schools in those days, they suffered a lot. You have to rank. Who is the first student? You have a chunk of data. But in Excel, you just rank it. One button ranks and arrange everything. You don't need 5 days to look at one small mathematics. So you highlight this.
Take this, take.
So recommended charts, as a recommended chart, recommend charts for you. So it's not as if you must use what is recommended charts. No. So Excel is telling you that according to your data, I propose the following. You can also know, please, this is not what I want. So recommended chart, see that we have varieties. If I'm using this, male, female. Which one is this? This is bar chart. Hmm? I have to be very careful your labels. Not all of them are the same. Look here. The legend here is frequency percentage. But this one is not the same. It's male, female. So you have to know well. You click on OK. Now with this, I can easily do my modifications. The font size, whatever. Now, there are three icons on the top right-hand corner of the chart is to modify your chart. The first gives you the axis title, data labels, data table, because you can include table and the chart in one. Error bars, you don't use error bars anyhow. Error bars are being used for mean presentations. So anywhere I see error bars, I know these are mean results. So I cannot count for gender, you are using error bars. It's very wrong. Error bars, you use it when you have what? Mean presentations. So you have the second section, which has to do with modification of your chart. So you can decide, no, I don't like me this one. I like me for this one, or this one down here. And the rest. So generally, you can use this to plot many charts. Are we there? Based on your data. You have the line graph, the pie chart. Sometimes you can fragment them or separate them like that. You know that the concept of a pie chart normally is a cycle, right? And cycles, you have to start thinking of what? Angles. Start thinking of angles. So normally you can calculate the angles here. You see? Yes. So that we cannot go so much detail. So please, summarily, we have done data exploration. We have done data descriptive. And we have looked at some aspects that, and we have even gone further to inferential. Chi-squared. And we are saying that chi-squared is for categorical data. It's not for continuous. It's not for this, for categorical data. So you have to know when to use it. And it's also inferential. Then we have said that statisticians will mostly use three confidence intervals. You have 90%, 95%, and have 99%. And you have to be able to know when your data is significant and when it is not. You have to know when it is significant and you're able to know when it is not significant. You need to know how to present your demographics and your results using charts in Excel, line graphs, bubble plots, is it funnel chart, and the others. Is it clear? So please, if there's any question, we take questions. If not, I think I'm still owing people about 51 minutes. If not, we go break. We break for 5 minutes. When we come back from break, we are going to look at chi-squared, how to calculate chi-squared in Excel. That also help you to now to use Excel to compute. Are we together?
Okay, sir.
Is it clear, Mr. Franklin? Please.
Dear, happy Sunday. Evening, pa. Are you back in town? How can you go to our in-laws without taking me along? Okay. Our grandmother wear a sharper. So when to play your duties. That's good. That's good. I love that.
that so we're asking that a variable in simpler terms is or has to do with more than 2, right? Or has more than 1 outcome. Do you understand? A variable can be defined as something that has more than 1 outcome. Is it okay now? So that's why we say gender is a variable. Why? Because it has more than 1 outcome. You have male and female. Color is a variable because you can have black or those who are fair, and so variable has more than what? 1 outcome. Categories are the building blocks of a variable. You understand now? Categories are the building blocks of variable. So when I'm using the term categories, variables, we should understand. We are going to get to other terms like indicators or indices or constructs. So you have the sample size divided by number of variables that's divided by 5, which will give you 12. So you see that the expected counts for this study is what? 12. So the next section which I'm looking at, observe minus expected. Observe minus expected. First of all, put an equal sign. You click on the cell. You can equally just click on the cell. Observe. You put your minus sign. Minus what? Expected. That's all. And you take enter there. You scroll down. Are you following up? So after this, we have to square the numerator. So it's observe minus expected numerator squared. So you first of all start by putting an equal sign. This, you have this squared. How do you get squared on a keyboard? You press Shift and 6. Square. So after having this, we have to divide this by the expected, right? So we have observe minus expected numerator squared divided by what? Expected count E equal sign this slash this, enter. Just hold this small box at the bottom right hand and you just lock it down. Now, sometimes when you export your data from Excel, you might need to put it to 3 decimal places, 4 decimal places, and the data is too much. There's no need for you to be stressing going through all those procedures. When you come here under general, this is decreased decimal. What's it, are you seeing? Decreased decimal. This one is increased decimal places. So we want to make them homogeneous by putting them at 2 decimal places. I have to come here, decrease decimal. I want to put them at, let them be homogeneous like that. You see? Then now you take the sum, you highlight all of this. You can come and take what? Auto sum. You click. This is the Pearson chi-squared value of 36.50. So, have you understood to this stage? Franklin, are you okay now? All right. So let me take it again. I said, generally, for you to compute Excel, you need to put the equal sign. After having the observed count, expected is sample size divided by number of variables, and you easily compute across. Now, after having the expected count here of 36.50, you have to look for the value of the critical value on the chi-square table. The critical value on the chi-square table at DF, degree of freedom of 4, that should be about 9.488. Because normally, when you're computing this, you need the chi-square table. You can get that online. So at degree of freedom is n minus 1. So OK minus 1, number of variables minus 1, sample size minus 1. Yeah. So after having that, you have to compare now your critical value with the calculated value. Now, this is the calculated value of 36.50. The critical value at DF of 4, degree of freedom of 4, to about 9.488. Now you have to compare 9.488 with 36.50. You see that 36.50 is greater than 9.488. Now, when your calculated value is greater than the critical value, you reject the null hypothesis. When your calculated value is greater than what? The critical value, you reject the null hypothesis. So therefore means you accept the alternative hypothesis. And vice versa. And vice versa. So in this case, the hypothesis for this study was that one, weight has an effect on arrival. So you see that weight has a significant effect on what? The arrival time. Because we have calculated, and this value is greater than what? The critical value. So we end there. That's why you just download the chi-square table. It's online. Download the chi-square table. See, this is it. Let me share it so those who are online. So if you look at, are we seeing? So this is it, 0.05 at the F of 4. That's the 9.488. No, you don't calculate the critical value. You get the degree of freedom. Then look at your alpha level. You get your value. So please, can we do the exercise now? 540. You cannot review. I've reviewed about 2 times. Let's start from the beginning. Observe count in simpler terms is the data you collect from the field. So we are saying that 30 persons strongly agree, and the rest follow, and we have the results those. They're expected now to compute so that you can come up with their justification at the end of the day. So how do you calculate the expected count? That's the first step. Expected counts is sample size divided number of variables. So the sample size here is 60 divided number of variables, which is 5. You get the expected count. Then you now proceed now to deduct now the observed from the expected, and you square it divided by the expected count. You get the total sum of the Pearson chi-squared value. And you now compare it now with the critical value that 9.488. Yes. So that your conclusion should be based if the calculated value is greater than the critical value, the one that is from the chi-squared table. If it's less than, then you have to accept the null hypothesis. You see? We are saying that normally we are calculated Pearson chi-squared, right, is greater than the critical, you accept the alternative. If it's less than, then you accept the null. So can we now continue from expected counts? Are you done? You are done calculating. No, you have to do it. Not we. You are done. What is your chi-squared value? So we are saying that you put the equal sign. That's the first step. Put the equal sign. We have put the equal sign. You divide the sample size on the number of variables, which is 5. You have 12. You pull down. Go to the next section, you put the equal sign. You can locate, or you can just click on the cell, put a minus sign, you click on the expected, and you take enter. Pull it down, compute for the rest, put the equal sign, click on the cell, Shift and 6. Pull it down. And the last section is this divided by expected count. Enter. And you pull it down. Which one? No, it's not necessary. So let me just give the resume of this stuff for today. Okay, so generally today we have covered aspects of descriptive, and we have looked at charts. We have looked at chi-square test to look at for analysis of for inferential analysis of categorical data. And we have also looked at how to compute using Excel, you can calculate using Excel, wherein we have computed non-parametric chi-squared, knowing that when it comes to inferential techniques, you are supposed to state your hypothesis and end with the one you have supported, or the hypothesis you have. You end with the hypothesis you have accepted based on your findings or based on your computation, sorry. So please, if there's any other thing, you could ask, but if not, by God's grace, tomorrow, we have to look at data testing to check for if your data is normal. Because after describing your data, you are now supposed to check if your data is okay or not. So we shall be looking at various tests for tomorrow. Please just read on the following. We'll look at skewness, ketosis, we'll look at the KS test, we'll look at Shapiro test to check for normality. Then same tomorrow, we'll be looking at data transformation. Data transformation, number one, we shall be looking at log transformation, inverse transformation, square root transformation. So you have log, inverse, square root transformation. When do you use log transformation? When do you use inverse, square root? And how can you test for normality? So please read on, even on PP plot, quanta plot. You can also go as far as looking at box plot. So please come tomorrow when you have read, please, so that it will be very easy for all of us. Is there any other question? Good. How do you interpret? How do you interpret one? Now, when you have to compare your calculated chi-squared value to the one you have from the table. The one you have calculated is greater than the critical one, the critical value. You accept your alternative hypothesis, and vice versa. So, okay. So I said there are three ways of testing, looking at significance, right? So you test using that, you test using p-values, confidence interval, the Fisher value, the Pearson chi-squared value, and the experimental value, or the value, the critical value, better said, sorry for that, and the critical value.
Class, see us tomorrow, and maybe by tomorrow we'll also reinforce what we have learned. I'll check if we have some previous recordings so we can go through with respect to the present content. By now you should be able to at least do descriptive and explore your data. Those are the basic ideas that you have to understand before you start going into inferential. Inferential is a focus, but then understanding descriptive is very, very important. So please, it seems as we're not taking the issue of coming on time serious. It's a critical issue. We don't need to come and wait till 3:15. We said 3:15 was the latest time, but you're supposed to be here 3 p.m. to take the notes either through Flash or if you download online and be ready for a class. I'm the kind of person I don't like to come and sit and I'm waiting for persons to come to class. Please, let's be on time. Time is very, very important. So see you guys tomorrow.